Okay, this video is over Chapter 8 of your textbook, which is titled More About Strings. So we're going to dive a little deeper into characteristics of strings and methods you can call on strings and that type of thing. We're going to talk about some of the string operations. We're going to go back and talk about slicing, and then we're going to talk about testing characteristics of strings, searching strings, and manipulating strings. So a lot of things happen on strings. For example, when we read input, even if we're wanting to read a number, it gets read in as a string, and then we have to convert that to one of the numeric types if that's what we are planning to do. Strings are sequences of characters. So a lot of things that we can do on list or arrays, which are really list, we can do on strings as well. We can go through and, like, we use a for loop to look at each element of a list. We can actually, if we call a for loop on a string, it will go through and give us character by character characters from that string. So, if we wanted to count for a certain character, for example, they're saying here, we could go through all the characters, and if one of the characters matches that character, then we would increment a counter or something. We can also index strings like we do list. So, if we say list at position 1, we get the second element of the list. If we do my string of 1, we would get the second character of string, because again, the indexes are going to start at 0, just like they do for list. So this is just showing you, if we were iterating over a for loop, each iteration of the loop would move to the next character in the string. So we see here that we're processing the string Juliet one character at a time. This is showing you that the indexes start at 0. It's also pointing out that spaces are characters as well. So position 5 and position 9 are going to be space characters. Here they're just showing you that my string is a reference to the entire string, and a particular character at some point would be pointing to one of the characters in the string. If you try to index outside the range of 0 to number of characters minus 1, you're going to get an index error, just like you would in a list. If we need to know the length of a list, we use the len built-in function. Same thing works on character strings. We can ask for the length of a string, and it will tell us how many characters are in that string. We can concatenate things together using the plus operator or the augmented assignment operator, plus equals, to concatenate strings together. One thing that takes a little to think about is strings are immutable. Once they're created, they can't be changed. So if you try to specify a specific character in string and change it to some new character, that's going to raise an exception. So basically what's going to happen is, here they're using string concatenation, which would appear to you as if you were changing the string, which would contradict what I just said, which are strings are immutable. But in reality, when you concatenate a string, it's going to take and assign it back into the same string name. It is going to take the name, in this case Carmen, and add the Brown to it, and then it's going to create a new immutable string that has Carmen space Brown in it, and then it's going to change the reference through the variable name to point to that new concatenated string. So it didn't, although it appears to have changed the name string, or the string that name was pointing to more accurately, it does not. It creates a new string and then puts the pointer to that. We can slice strings just like we do arrays. If we take a portion of a string, that's called a substring. We do it the exact same way. We have string name and then a start colon end value, and it will pull the characters out of the string just like it pulls values out of a list. We can have a step increment, we can have negative increments, all the things that we have for list we can do to character strings in the context of slicing. We also have an in operator that we can say is one string inside another string, or is a particular character in the string. A particular character is a string of length 1 basically. You can say not in to determine if it does not include a particular string. Strings have methods that you can call. When you have an object, in this case a string, and you call a method on it, you put object period method name and then in parentheses arguments. If there are no arguments to the method, then you would just have open parentheses, close parentheses. The things that test whether certain things are true or not about strings are Boolean methods. That means they are methods that will return true or false and no other value. Here's some methods. Is it alphanumeric, which means does it have letters and digits? Is it alpha, which means it's strings only? Is it digit, or sorry, is digit means is it only digits? Is lower, if every single character is lowercase. Is space, returns true if it's only white space. So I know I've talked about white space a lot when I taught CIT 145, which was Perl programming. Python is very similar to Perl in a lot of aspects, but in case you haven't turned or haven't covered or know about white space characters, basically white space characters are one or more characters for which you see the result of the character being there, but you don't see the character itself. So the easiest is a space. One space will separate words, but you don't actually see anything there. If you have 5 spaces in a row, the words will be further apart, but again, you do not see the spaces, you see the effect of the spaces. So one or more spaces is white space, a tab is white space, a new line character is most of the time considered white space. So that's what white space is. So is space will tell you if there are only white space characters in the string. And then is upper will tell you is the string composed of only uppercase characters. So those are some of the string methods that might be helpful to you. So some methods copy a string, so it appears as if it is mutable when we know that strings are immutable, which basically means it will take a string, make a copy of it, or it will modify the string and then assign it to a new variable, or possibly even back into the same variable to make it look like you can make changes to it. When we're comparing things, we have by default, the comparison is case sensitive. There are lower and upper methods which will either all lowercase or all uppercase a string. So if you're looking for the user to enter a lowercase y, what you might do is take the input they gave you and apply the lower function to it, which will take a capital Y and change it to a lowercase y, and then make that condition true. Because even though you programmed it to take lowercase y's, if the user types a capital Y, most of the time you're going to want to consider that a yes answer as well. Here are some things that are more handy methods. If you call lower, it's going to convert everything to lowercase. If you call lstrip, it's going to remove characters from the left. By default, this is going to be leading white space if you do not pass an argument. If you do pass a character to it, it's going to return or strip one or more occurrences of that character at the beginning of the string. There's rstrip function that functions exactly the same, except it refers to the end of the string instead of the beginning. If you do strip, it will do beginning and end at the same time. So a lot of times if the user, you say type in the user's name, if I, for example, went space, 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 Wayne, space, space, I would really want that to be Wayne. So anytime I ask the user for input like that, I might want to call the strip function on it to get any extra leading or trailing spaces. Now if I put Wayne space beach and called strip on it, it would leave that space in the middle there because it's not a left or right occurrence of white space. And then upper will convert everything to uppercase like we said before. Substrings, we often need to know if a string occurs within another string. So we have substring. We can say ends with a substring or starts with a substring, and it will return true or false if it ends or starts, depending upon which function you called. If we use find, it will look for occurrence of the specified substring within the string object that we're calling find on. We can do substitution, which is find substring and in its place put some new string. So this is just kind of talking a little bit more and showing you the syntax again of calling those methods we just talked about. We talked about the repetition operator in the context of a list. We can use repetition on strings as well. We can put a string and then put star and a numeric value. So if for some reason in my output I wanted to draw 10 equal signs to separate sections of my output, I could say equal star 10, and that would give me 10 equal signs, and then presumably I would be printing that in the scenario I just gave you. There's a split method which is handy for taking strings or data read from a file and breaking it apart. By default, if you call split with no arguments, it will split on white space. If you have, for example, a spreadsheet that is a CSV, which means comma separated values, we might read a line from the spreadsheet and then split it on comma to break it into the different columns that our spreadsheet has. So there's a couple examples of using split. Here we have strings and we want to break it into words. So we say our word list is my string.split, and then we don't put any argument in the parentheses, which means split on white space. So we end up with a 4-element list: 1, 2, 3, and 4. If we put slashes here, for some reason they have a bunch of numbers, but for example, if we had month/day/year and we wanted to split that apart, we could specify the character to split on as being a slash, and it would break that string apart, and the character that we're splitting on, notice that it goes away. So nowhere do we end up anything with a slash in the second example. A lot of times when you split things apart, or take values and separate them by some character, we refer to those as tokens. So here we have strings that are separated by space characters, and those individual strings, peach, raspberry, strawberry, vanilla, in these cases are referred to as tokens. The character that separates those tokens is referred to as a delimiter. Here we have tokens that are separated by a semicolon. So they're just giving you an example of a different delimiter that we haven't seen before, separating numeric values in this case. Tokenizing is the process of taking a string and breaking it apart into tokens. Like I said, you break them apart and store them as individual values. And one of the most common ways built into Python to tokenize a string is with the split function. That's exactly what it was designed for. Here's some examples of splitting, again in the first case on space, in the second case on a period. So in the second case, we're taking a web address and breaking it into the various parts, which are going to become what we have as the tokens. So that's the end of Chapter 8. That is some additional information about strings and methods that you can use with strings. We'll be using a lot of these throughout the semester. And of course, what we have here is just a brief summary of all the things we just talked about in Chapter 8.